Now we will discuss a particular case of m by n contingency table. In m by n contingency table, a attribute A is divided into m subgroups, whereas B is divided into n subgroups. But in 2 by 2 contingency table, we are dividing A by only two groups and B by only two groups. So A is divided into two groups. For example, sex is divided into male and female. So we will take A as male, whereas B as female. And this empathy is divided into, so whether there is a high empathy, so this is taken as H, B1 is my H and B2 is my low. So empathy is my attribute B and sex is my attribute A. Sex is divided into two groups, male female, and empathy is divided into two groups, high and low. So this type of classification is called as 2 by 2, and this representation 2 by 2 is nothing but 2 by 2 contingency table. Now how to test whether the two attributes A and B are independent or not with the help of 2 by 2 contingency table. So now we will discuss this. So this is a particular case of m by n contingency table. So what is my hypothesis? See, the test is again, so this is my first step. Step number 1 is hypothesis testing. Step number 2 is test statistic. Step number 3 is nothing but the critical region is my third step, and fourth step is nothing but my conclusion. So in this way all these testing procedure we are doing. So now we will start with setting our the hypothesis. What is my hypothesis in this case? The hypothesis is both the attributes A and B are independent. And what is my alternative hypothesis? The attributes A and B are not independent. So that means they are dependent in the sense they are associated with each other. Both the attributes are associated, and in this case my null hypothesis is both the attributes are independent. So independent is the null hypothesis, association is my alternative hypothesis. See, A is divided into two groups, B is divided into two groups. So what is this A? A is nothing but my observed value. So A is my observed value, means how many males are there who are representing high empathy, and how many, so what is this C? C represents the females having high empathy. And what is this B? B is nothing but the males having low empathy, whereas D is nothing but my females having low empathy. And what about these values? A plus B is nothing but my frequency of class 1. So class 1 in the sense A1, A is divided into, so this is nothing but my male. So this is what? This A1 represents male and A2 represents female. So what is this A plus B? A plus B is nothing but, A plus B is what? A plus B is the total males. C plus D is nothing but total females. A plus C is what? A plus C is nothing but the high empathy total, and B plus D is nothing but the low empathy total. And now we need to understand whether sex and empathy are related. So that means this is, or they are dependent or independent. In null hypothesis we are saying both the attributes A and B, both sex and empathy are independent, whereas in alternative hypothesis we can say that they are not independent. Not independent in the sense they are dependent, they are associated with each other. See how many rows are there? The number of rows are 2, whereas the number of columns are 2. So 1 degree of freedom is lost from row, 1 degree of freedom should be lost from column. So therefore 2 minus 1 is 1, 2 minus 1 is 1. So 1 multiplied by 1 is 1. So we need to take the table value from chi-square 1 with respect to the level of significance. So how we can calculate this? So to test that whether attributes A and B are independent, so we know what is the formula for m by n contingency table. in case of m by n contingency table, this is my formula. So chi square is equal to double summation Oij minus Eij square divided by Eij, which follows chi square m minus 1, n minus 1 and alpha. Since we have only two divisions, A is divided into two subgroups and B is divided into two subgroups. So this is nothing but my 2 by 2 contingency table. So therefore, the number of rows are 2, the number of columns are 2. We can subtract 1 from row and 1 from column, so that becomes our 1 degrees of freedom. And O11 is my first observation, that is A, O12 is B, O21 is C, and O22 is my D. This is my observation D. So this is my O22. So we can calculate the value of chi square by using the same procedure. So O11 minus E11 square divided by E11. So likewise we will take all these four values. So these are the four values and calculate. Once we calculate this value, so what we are getting? We are getting this value as AD minus BC square divided by N into A plus B into A plus C. So for this value, for first value, so that means O11 minus E11 square divided by E11. So this value is what? So this value is nothing but AD minus BC square divided by N into A plus B into A plus C. Likewise, we need to calculate the second value, the third value and the fourth value. So for each value, we need to calculate the expected value. So that means this is my observed value. So what is observed value? Observed value is A. I need to calculate expected value of A. I need to calculate the expected value of B, the expected value of C, while the fourth one is the expected value of D. And all these values we have calculated. Only difference is in the denominator. So the first value for A, we are taking A plus B and A plus C. For B, we are taking A plus B and B plus D. For C, we are taking C plus D and this is A plus B. And for the last value D, we are taking C plus D and B plus D. And finally, we are getting the value as N into AD minus BC square divided by A plus B, C plus D, A plus C into B plus D. So what happens if any cell frequency is less than 5? If any cell frequency in 2 by 2 table is less than 5, then for the application of chi-square test, it has to be pulled with preceding or succeeding frequency, so that the total frequency should be greater than 5. This result in loss of 1 degrees of freedom. Since for 2 by 2 table, degrees of freedom is 1. The degrees of freedom left after pulling are 0. See, 1, suppose if you pull this value, 1 degrees of freedom should be lost. But initially there is 1 degrees of freedom. After pulling, again we are subtracting 1 degrees of freedom. Therefore, the total number of degrees of freedom are 0, which is absurd. So in such a situation, we need to apply the correction, and this is given by 8s. We call this as a 8s correction. So this consists in adding 0.5 to the cell frequency which is less than 5. Suppose any cell frequency is less than 5, we need to adjust this value and adjusting the remaining frequency accordingly. Since row and column totals are fixed, and then applying chi-square test without pulling. So we need to apply the chi-square test without pulling. So therefore, so what we have to do in this case is the chi-square test now becomes, the chi-square test in this case now becomes AD minus BC minus N by 2 square divided by A plus B, C plus D, A plus C, B plus D. So follows chi-square with 1 degrees of freedom. So this is my calculated chi-square, this is my table chi-square. If calculated chi-square is greater than table chi-square, we need to reject our null hypothesis and accept otherwise. So this is the test for chi-square test for 2 by 2 contingency table, where there are two cases: if the cell frequency is less than 5 and if the cell frequency is more than 5. So this is all about chi-square test. We will stop here and continue with one more test in the next lecture. Till then, goodbye.